Hey guys, here's your video notes on how to do calculations with horizontal projectiles. Alright, so um, you could write down the title here, horizontal projectile calculations. Actually just pause the video for a second, and if you want to right now, and you could copy everything that's on this piece of paper, and then I'll explain it after you unpause it. Alright, so hopefully you unpaused it, and now we could copy it down, and we could go through it and explain it. Um, what we're going to be calculating today, basically, if you fire something horizontally, how far will it travel before it hits the ground? How far, meaning like left to right, how far is it going to travel until it hits the ground, okay? So how far from where it was shot, basically. All right, so um, what we do first for the calculations is we use our old x and y axis, all right? So x is just we're gonna use that term x to mean anything that is horizontal, all right? So anything left to right, we'll say x for, all right? So if we measure a distance from left to right, that's a distance x, or a dx. And we'll use y as a letter to mean anything that is vertical or up and down. So gravity would be something that we talk about in the y direction, or any kind of height, something that's measured up and down would be also a y type of thing, all right, a vertical type thing. All right, so next we're going to look at a little table here. You're going to have three variables, all right, that you're going to be asked this week to calculate two out of the three. But there are three variables you'll be given and have to understand. Left to right distance, or dx here, otherwise known as the range, is measured in meters. So you have a little unit here for meters. We also measure distance up and down. So maybe if someone throws a ball, how high up did they throw it from? That would be a distance, but it would be a distance in the y direction. And if your problem says anything about height, that is a distance in the y direction. So it's dy. And that's also measured in meters. Our last variable is how fast is something shot, or how fast is something thrown. That's velocity or speed. And because we're talking about horizontal projectiles, we're only throwing things left to right, all right? Not up, not down, just left to right. So it's a velocity x, we're going to call it, because it's a left to right throw, a horizontal throw. And the unit for velocity here is going to be meters per second, all right? So those are your three variables. Today we're going to practice calculating just one, distance in the x. All right, we're going to show you if I told you how fast something is thrown or shot, and if we told you the height that it is thrown or shot from, how high up it was, how you could calculate how far it's going to go before it hits the ground. Okay, and that's what we're focusing on today, is calculating dx. All right, so there's two equations you need to know here. Why don't you just pause the video real quick, and you could copy down the two equations right there, all right? Now I'll explain them. Okay, so hopefully you've copied down the equations. Your first equation is an equation about y, okay? It's distance in the y, or the height, in other words. Remember, that is the height. If you read height in the problem, it gets plugged in there for distance in the y, and it has 1/2. You could put it in parentheses if you like. It doesn't make a difference, really, whether it's in parentheses or not. Times g. Remember, g is equal to 9.8. It's the acceleration from gravity. Remember, half of 9.8 is 4.9. You could use that number if you'd like there. t squared, right? Only the time is squared. So you're familiar with the equation, hopefully. And that equation is only about the y direction, not the x. Because that's gravity. Gravity is a vertical thing, so it's in the same equation as height, which is also a vertical thing. Distance in the x, all right? That is what we call the range, how far something's going to go, all right? Equals the velocity in the x times time. That's our second equation, all right? So only two equations. This one's used in the y, this one's used in the x, all right? And now let's do an example problem and show you how to figure out how far something goes. Okay, I'll fold this paper here real quick. Why don't you take a second and copy down this problem right here, all right? Solving for dx, or range,